One of the concepts that I had a hard time getting my head around when I started working with Python is the concept of args and kwargs. And that is mainly due to the fact that most of the tutorials out there cover kind of a limited perspective about the topic. So for quite some time I believed that args and kwargs are complicated and counterintuitive, and it took me a while to figure out that most of my confusion was due to my lack of understanding rather than due to the complication of the topic itself. So today I want to provide you with an extended or alternative view about args and kwargs that will hopefully give you a deeper understanding and will hopefully allow you to apply args and kwargs to simple function calls as well as to function calls that appear to be more complicated. As usual, you should have at least some basic Python knowledge in order to follow. And with that out of the way, let's dive right in. In this little Python snippet, I have two data structures. One is a list called args, the other one is a dictionary called kwargs. Down below I have two print statements to print these two data structures. And if I print those, you can see that Python prints both structures as expected. In order to explain to you the concept of args and kwargs, let me first give you a short introduction of how to use args and kwargs from within a function call. In order to do that, I create a function called addAb, which adds two numbers together, and I pass in the arguments list args from line 1 as a parameter. I then create a total by adding the first two values from the list together, and because these are lists, I can refer to these values by their positional index. I then return the calculated total value, and I call the function from the outside using a print statement. In the print statement, I call addAb, and within the calling brackets, I pass in the args list as an argument. If I now run the function, you can see that Python prints 6 as a result. And the reason is that we have added the two values at the 0th position and the first position of the args list together. And these values are, of course, the values 2 and 4. We can run the same function call using a keyword arguments dictionary. In order to display that, I will replace the args list that I passed in from line 1 with a keyword arguments dictionary from line 2. And because we're dealing with a dictionary here, I have to switch the single star for a double star to unpack the dictionary. In addition to that, because we're dealing with a dictionary inside the function now, I have to replace the positional index that I used for the list for a named index as we use it in regular dictionaries. And if I now rerun the function, you can see that again it prints the number 6. But this time it has taken the values a and b from the keyword arguments dictionary. What I have shown you so far might be syntactically correct, but it's also entirely pointless to do, because you can achieve the same result by just passing in a regular dictionary without doing all the packing and unpacking in between. In addition to that, you can actually rename your dictionary to something much more meaningful to make your code more understandable and more readable. As you can see here, even though we removed the stars and renamed the dictionary, we're still printing the number 6 as a result. So as a first takeaway, you should realize that the namings of args and kwargs are just conventions in Python, which I encourage you to break, especially in case you can give your data structures much more meaningful names. In order to fully comprehend why we do all this packing and unpacking for args and kwargs within a function call, you should be familiar with how Python unpacks values from data structures into variables. So let me introduce you to the art of unpacking complex data structures in Python into variables. In order to show that, I create two variables a and b and assign it the list args from line 1. I then just print a and b. As you can see here, Python has printed 2 and 4, the two values from the args list that have been passed into a and b. And to make it a bit clearer, let me add a string here at the beginning of the print statement and rerun the statement. And then you can see outside function here we have 2 and 4. So what happens if I add 2 more numbers to the args list and then rerun the program? As you can see, Python returns an error message resulting from the fact that I tried to pass 4 values into 2 variables. If I add these 2 variables c and d here and rerun the program, you can see that it runs without errors. And if I add c and d at the end of the print statement, then you can see that Python actually prints all the values that I have added to the list in the first place. So the second takeaway from this video should be that whenever you do this kind of unpacking of data structures into variables, make sure that you have the same number of elements on both sides of the equation. But what happens if you don't want to unpack an entire data structure into an equivalent amount of variables? In this case, within the same statement, Python gives you the option to kind of repack some of the values back into one single variable. You can do this using the star indicator. As you can see down below, Python has unpacked the two first values from the args list 2 and 4 into the variables a and b, and it has unpacked the remaining two values 6 and 8 as a list into the variable c. It has done so because the star indicator in front of the variable c indicates to Python to eagerly unpack all remaining values into c. But it gets even more powerful, because the star operator, as you see here, is not limited to the last position of your variable array. Instead, in this example, I can move it to the middle variable b, which will change the entire unpacking logic. As you can see now, the first and the last value have been assigned to a and c, and all the middle values of the array have been assigned as a list to the variable b. So much about the unpacking of tuples and lists, but what happens if we try to unpack a more complex data structure, such as a dictionary, for example? In order to verify what happens, I will take the dictionary from line 2 and I will unpack it in the same way as I have done with the args lists here. So if I change args for kwargs here in line 8 and rerun the program, you can see that down below Python has not assigned the values 2 and 4 to the variables a and b, but instead it has taken the keys from the dictionary, namely a and b, and assigned them respectively. This is kind of a default behavior in Python that whenever we refer to a dictionary just by its name, it's assuming you're referring to the keys of the dictionary. As a little side note, you can unpack the values of your dictionary by adding .values and then the calling braces at the end of your dictionary. But what happens now when you put the two stars in front of kwargs and force Python to unpack all keys and values from the dictionary and assign them as keyword arguments to a and b? As you can see here, Python throws an error message telling us that an assignment via keyword arguments is not possible in this kind of statement. So takeaway number 3 would be that the double star indicator is limited to cases where keyword arguments can be used for assignment purposes. And that is of course the case in a function call. We have now learned how Python uses unpacking to assign multiple values from a data structure to multiple variables in just one single statement. We also have learned how the star indicator causes Python to kind of recollect all remaining unassigned values into a list and assign them to the variable that carries that very star indicator. The main reason why unpacking can be useful for a function call is that these equal operator behave very similar to the parameter assignment during a function call. In other words, the relationship between this kwargs parameter here and this kwargs parameter down below in the function call is very similar to an equal sign. This can be very helpful for the way we usually use functions. Because functions can be used by multiple different programs, we want to keep the naming conventions within the functions independent from the programs that actually call them. Like in this example, we don't want to add kwargs A and kwargs B. Instead, we might want to add X and Y. But this would now mean that you somehow have to assign kwargs to X and Y, and unpacking is actually a way you can use to circumvent that. So for the args list from line 1, this means that we can pass it into the function call, but then for the receiving parameter set in the function definition, we specify X and Y as the receiving variables. However, if we try to run this now, Python will throw an error message. And the reason for that is that, unlike the equal sign, the function call does not eagerly unpack all the values from args into X and Y. Instead, Python will attempt to assign the entire args list to X, and therefore will leave the variable Y unassigned. So how can we enforce Python to unpack the values? And this is where the star operator comes in handy. If we put it in front of the args argument within the function call, Python will enforce unpacking and assign the two values from the args list to x and y. If we rerun the program now using the star operator, Python will return 6 as we expect to get if we add 2 and 4. Now what if we add additional values to the list, in this case 6 and 8, and rerun? In this case, Python again throws an error message telling us that it cannot unpack 4 values into 2 variables. So we have to add c and d down here in the function definition. And if we now rerun this, and of course we also have to add 2 variables here in line 8. If we now rerun the program, you can see that again 6 has been printed. And like in the unpacking example before, you might not want to use c and d inside your function. So you can use again the star operator to repack all unassigned value into one single variable c. So in this case, only the values 2 and 4 have been assigned to the variables x and y, but you still have access to all the remaining values 6 and 8 via the variable c. You might call this variable args to indicate that it contains unassigned arguments. So if I print args now in the function down below and rerun the function, then you can see that Python actually prints 6 and 8 for args. So what if we want to do the same thing with our kwargs dictionary in line 2? As you have seen previously, we cannot unpack a dictionary into a regular assignment. But inside a function call, we can actually use dictionary unpacking. But because we're dealing with key value pairs now, the keys of the dictionary values that we want to assign have to match the names of the variables into which we want to assign them to. So if you unpack a dictionary into a function call, then within the function definition, Python will look for variable names that match the keys from your dictionary. And if it finds some, it will assign the values from those keys into that variable. So if I recall my function now using **kwargs, and of course I have to make sure that my dictionary contains both keys x and y, then again Python prints 6, which now is the total from the two dictionary values x and y, so 2 and 4. And just to prove the point, let me change the y value to 5 here, and Python prints 7 now. Similar to lists, our dictionaries can contain multiple values. In this case, I will add the two values t and k. And if I rerun the program now, you will see that Python throws an error message again because now it cannot assign the two key value pairs from t and k. In order to allow the assignment, we have to go down to the function definition and add t and k. And if we rerun the program now, you can see that Python prints 6 again because right now we're not using t and k within the function. And because we are not using them, we might actually not want to explicitly define t and k. So similar to what we have done with args, we can specify a **kwargs object here that collects all unassigned arguments into one dictionary. And if I now print kwargs within my function, then you can see that the print result contains t and k, the two unassigned values from our original kwargs dictionary. So just to recap, I'm calling @ab using my kwargs dictionary from line 2. And because I've specified the variables x and y here, x and y are specifically unpacked by the function call, and I can now use them within my function. Also, because I have specified a kwargs object here, all the remaining values from the dictionary will be assigned to that kwargs object. We can at any time combine args and kwargs by just adding the *args argument at the beginning of the function definition parameter set. And also in the function call, we have to add *args at the beginning. If we rerun the function now, you see that nothing has changed. However, we can also unpack parts of the args list into the function definition. In this case, I added the two variables a and b, which will unpack the first two values of the args list into a and b. And if I now print a, b, and args inside the function, you will see that a and b contain the values 2 and 4, and the args argument contains the two values 6 and 8. Note that, unlike what we have seen with a regular assignment, it is not possible to move the star operator to one of the previous variables within the assignment. This will throw an error message because the star operator in here eagerly exhausts all the assignment values to B. Because of that, args will be treated as a keyword argument, and because the kwargs dictionary does not contain an args key, it will remain unassigned. So keep in mind, if you want to collect any unused arguments into a list during your function call, you can only do that with values that are positioned at the end of your originating list. Although this single function example already gives you an impression about the power of unpacking during a function call, the real power comes to light once you call multiple functions within your program using identical data input structures. In order to demonstrate this, I create a second function called addTk, in which I will add the two variables t and k together and return the total. I will now call this function using keyword args only, and I will remove the args argument within the function call. If I now call the function, as you can see, Python returns 14, which is the total of t and k, 6 and 8, that has been calculated within our function using the two values t and k from our kwargs dictionary in line 2. As you might realize now, unpacking allows us to use aggregated data structure across our entire program and call multiple functions with it, while maintaining function integrity by splitting up the input data into meaningful chunks and assigning them through unpacking to meaningful variable names. Now that was it for today. Again, like the content if you enjoyed it, and see you next time.